Good morning, children. In this video, we're going to discuss about the next topic, interrupt hardware. Most of the computer have several I/O devices that can request an interrupt. A single interrupt request IR line may be used to serve an n number of devices. Where all the devices are connected to IR line via a switch to a ground. To request an interrupt, a device closes its associated switch, then it's going to perform the interrupt request. So as like that, all these inputs and devices are going to be connected to your switches as shown in the figure. Let's discuss about that. To request an interrupt, a device which is going to be having a switch which has to be get closed over there to request the interrupt request by the device to the processor. So thus, if all IR the interrupt request signals are inactive, the voltage of IR line is equal to that of VDD. The supply which have been given over there, this is equal to that of the VDD. When a device requests an interrupt, the voltage of this line VDD, which is going to get dropped to ground 0. Thus, the interrupt received by the processor is going to be made from 0 over here. Hence, it's going to give a 1 signal, and NOT gate is going to be making it as a 1. And this value of INTR is going to be logical OR. So the requested from the individual devices are going to be get additive. It's going to be in INTR1 plus INTR2, INTR1 plus INTR2 plus etc. INTRN. So a special gate known as an open collector or an open drain is used over there to do the operation of the INTR line. So the outcome or output of this collector line is equal to switch to the ground, that is open when the gate is in 0 and closes when the gate is going to be 1. Such a way, the resistor R, which is going to be a pull-up resistor, because it pulls the line voltage to the high voltage status when it's a switch is going to be get open, and it's going to be giving the information to this particular INTR. So which device is going to be get open, which device is going to get closed, there it's going to be processor is going to recognize that device, and that's going to be get satisfy its condition by the processor. Such a way the interrupt hardware is going to do its process. So the resistor R, which is going to make useful for us to act as a pull-up resistor to push or to pull the line voltage from the high voltage state, and all the switches are going to be get open. So no interrupt state is going to be produced when it's going to be get all switches are going to be get open, and when one switch is going to be get closed, so that particular interrupt line will be request will be satisfied for that particular input device. Such a way the hardware device is going to be get enabled, and it's going to be doing its operation as interrupt. Next, we have move on to the next topic called as enabling and disabling interrupt. Already we have come across this. There's nothing but a processor generally provides the ability to enable and disable such interruptions as desired. One simple way is to provide a mechanism which is going to be called as interrupt enable or interrupt disable for this purpose. To avoid the interruptions by the same device requesting the execution of an interrupt service routine. First, what happened? The first instruction of an interrupt service routine can be an interrupt disable, and the last instruction of an interrupt service routine can be an interrupt enable. During that time, what happened? When an interrupt can stop currently executing the program temporarily and branching to an interrupt service routine, an interrupt can occur at any time duration, the execution of the program. Because of the above reason, what happened? It may be sometimes necessary to disable the interrupt and enable it later on its program. For this reason, we are going to have this. The first instruction of the ISR is going to be an interrupt disable, and the last instruction of this same interrupt service routine can be an enable interrupt. Such a way, this enabling disabling interrupt is going to be useful for the processor to achieve the appropriate interrupted work done by the processor. Let us take an example of this recursive interrupt problem. Let's assume that an interrupt has occurred and the interrupt service routine is about to execute. The interrupt line is still high, and it may go low when only the interrupt line is going to be returned to the processor. This may take some time during when or which the processor may think that some more interrupt have arrived and need to be scheduled first so that the interrupt service routine do not lead to an infinite loop of the interrupt. There are two methods to handle the situation we are going to follow. The method one, as soon as the interrupt service routine is going to be entered, all the interrupts are going to be disabled. The interrupt are enabled only while exiting the interrupt service routine. Also note that the program written for the interrupt service routine has to enable and disable the interrupt in this case. This is done explicitly by the programmer. The user has to do that one. The second method, in case of a simple processor, the processor can disable. Okay, instead of manual, automatically the processor can disable the interrupt when the interrupt service routine is going to be entered. It will enable the interrupt when the interrupt service routine is about to exit the last instruction of the ISR. This method is going to be different from the first method, as in the first method we had to explicitly write a program for this interrupt service routine to enable and disable the interrupts, whereas in this case the processor has its own inbuilt mechanism to process this particular disabling task. Such a way we are going to do this particular disabling and enabling of this interrupts in this particular processor interrupt services. Let's see the sequence of events which is involved in the handling an interrupt request. The device raises an interrupt request. The processor interrupts the program currently being executed. Interrupts are disabled by changing the control bits in the processor status register PS. This device is informed that its request has been recognized. In response, the device deactivates the interrupt request signal, and the action requested by the interrupt is performed by the interrupt service routine. So interrupts are enabled and executed of this interrupted program is resumed. Such a way, the sequence of events are going to be get useful, and it's going to handle the interrupt enabling and interrupt disabling request in this particular interrupt process.